Let us solve the exercise number 1 in the part A of our data structure lab. In this exercise, we are supposed to sort the given list using selection sort. So we are supposed to sort using one of the technique, and that technique is the selection sort. Now we know that in order for us to sort the element, we need a list. So let's first write the program how to get that list, and then we will think of sorting it. So I have with me the code block. I'm going to go to the file here, and I'm going to click on file, new file. Okay. If you are getting, for those who are not familiar with using the mouse, if you find it too difficult to go to this file, new, and then selecting file, you can just click on this icon over here that says new file. So it will click on here and then select new file. So click here and select file, you'll get that. Okay, so I'm going to select the C++ source, and I'm going to click go here. It will ask me for a few details. Let me go to the next step, and in this step I'm going to say I'm going to make a C program, not the C++ program. So this is going to be a ordinary C program. I'm going to click next, and here I'm supposed to write the file name. Remember, very important thing over here is try to save your file at the proper location. Don't try to save it at any place and everywhere. So first click on this ellipsis over here, and then choose the proper directory. So I have selected some directory, like I have the under my D drive, I have a directory second BCA DS, and I'm going to save it there. So your teacher will tell you where you are supposed to save it. Save your file in that location only. Okay. Now give it a name. I'm going to say it is exercise A1, and I'm going to say selection. Okay, selection sort. If you notice there, I have not put any spaces there. I've kept it as a single file without any spaces in between. So it is just a single word. So exercise EA1 selection sort. Let me click on save, and then you will notice that it is now saved under D colon and BCA, and then whatever is the name. Let me click on finish to finish it off. As usual, when you are typing, if you find that the things you can't see it properly, then press down the control button, that is CTRL button, and in your mouse you have the wheel there to scroll. The wheel, scroll wheel is there. So either turn it down or up. You can increase or decrease the size of it, that is by zoom in or zoom out. You can do that thing. So let me zoom out a bit, and I'm going to type it now. So I'm going to say include, and I'm going to say stdio.h. Okay. So stdio.h, and that will be the header file that is required. Then I'm going to say void main, because I don't want to return anything. Now we need a list. How do you create a list? We will assume that all of them are integer. So we need an array. Let me say that there are 50 elements in the array. You will definitely know that during the examination, you may not type all the 50 elements. You may type less than 50 elements. So I assume that maximum is 50. Out of all these 50, so even though you have allotted an array with 50 elements, so there are 50 elements in the array, you may not use all of them. You may use the first n element, not all the 50. So even though allocation is there for 50, you will use n element out of it. And also, for us to go through individual element of the array, so you know that this is a array a of 0, a of 1, and so on and so forth. So for all these things, a of 0, a of 1, and for the other, you generally say a of I. So general, you are saying a of I. So we need this ith element. So I will use one more variable I for the time being now. Let me ask the user what is the total number of elements that are required. How do I do that thing? I'm going to say printf, and I'm going to say enter. Let me say enter total number of total number of elements, and I put the colon, and then I put one extra space here. So you notice that there is one extra space here, so that it looks nice. Then I'm going to use the scanf function to read the value. You know that it is a integer value, so I'm going to use %d, not the this one, %d, and then I'm going to use ampersand n to read these n elements. So I've read that n elements, and then once I have the n element, I'm going to say printf. Then I'm going to say enter values of %d elements. And then I'm going to put a colon and do that. So what is this %d? D will be n elements. So this is how it's going to come. So for example, if you type, if you input n as 5, then it's going to say enter let's say values for 5 elements. So done that, then I'm going to use a for loop to read all the elements. So I'm going to say for I is equal to 0, I less than n, I plus plus. So I'm going to do that thing. Then I'm going to use the scanf function. So generally you do this one. Some of you are familiar with this one. So whenever you see this for loop, you tend to put the flower bracket, but don't put the flower bracket if there is only one element. So if you have only one element for the for loop like this, if you have only one statement, not the element, or one statement for the for loop, there is no need to put the flower brackets. It's not really required. So I'm going to remove them so that it looks easier, and also during the examination you don't have to type too many things. So this scanf is part of the for loop now, even though there is no bracket, but it is considered as the part of the for loop. Remember, only the one statement, the second statement will not be considered as part of the for loop. So if there is only one statement, you use that thing. So we are reading n elements. Let me run that thing. I'm going to click on this one, build and run. So this option, I'm going to select this one, build and run. So it will compile, and it is going to say enter total number of elements. So let me say enter total number of elements. I'm going to type 5 here. Then it is going to say enter. So I typed enter total number of elements. Then I've inputted 5 here, and now it is going to say enter the values of 5 element, because n is 5. So it is going to say enter the values of 5 elements. So let me type 10 minus 5, 6, 40 and 4, and press enter. Nothing is going to happen because your program will end. After this, we are supposed to sort, so that we have not done. So we are supposed to sort. So let me put a remark statement here. So selection sort has to be done here. I don't know how to do the selection sort as of now, but I know that after I complete the sorting, I will have to display the sorted element. So I'm going to say printf, and I'm going to say sorted elements are, okay. Then I'm going to use the for loop, and I'm going to print all the elements. For I is equal to 0, I less than n, I plus plus. And because there is only one statement here, I'm going to say printf, and I'm going to say %d, and I will put one space here. If you notice, I put one space here, otherwise they will come, all the elements will come touching one another. So I will print all the elements of the array AI. So in this case, I'm inputting the elements into the array, and here I'm printing the elements back. Let me just run it. So this one, close this one first of all, then try to run it. So let me run it, and let me enter the values. Remember, sorting is not yet started. We are just doing the housekeeping work. So we have 5 elements here, and I'm going to say 56, 79, 3, 45, and press enter. And you will notice that sorted elements are, it will come as it is, whatever you typed, it will come back because the array is not sorted. Now let's learn about how to sort the element. Then you may ask, why did you do this, sir? You will ask that. So sometime what will happen is during the examination, you will forget the actual logic for sorting, because there are too many sorting techniques are there. So in that case, some of you will submit the blank page to the examiner. So don't do it. You don't know how to sort it, but there is marks for input, there is marks for output. These things are common for all the sorting. So if you just write this part, sorting you don't know, they will deduct the mark. They will definitely deduct. So you won't get to be won't be given zero, but you will give they will give you some appreciation mark. So if you don't know how to sort, do this part. That is enough. You will get some marks. I'm not saying that you will get a pass mark. That may not be true, but you will get some marks. Okay, so let's go ahead and let's try to sort the element using this selection sort. Now this selection sort, remember this one, selection sort, the word itself says you have to select. Selection means you have to select. Now the question is, what is that I am supposed to select? So if it is ascending order, you have to select the minimum element. So that is what you are supposed to do, or the least element. So you have to select the element that is smallest. Select the smallest element. That is why it is called a selection. You are selecting something. That is the idea of a selection sort. Remember that thing. So for bubble sort, you have something different. For selection sort, you have something different. So let's go ahead and let's try to understand how the sorting takes place. Okay, so let's assume that, so here when you have executed this program, so you said total number of elements are 5, and then you typed some elements here, some element, let's say 5 elements were typed. So assume that you have typed 5 elements. Somebody has given you the 5 elements like this: 25, 72, 98, and so on. So some elements are given here. It is altogether starting from 0 up to this one. There are 7 elements are there. So let's assume that somebody has given 7 elements and all of them are randomly placed, and you are supposed to sort them in the ascending order. Okay, what is the meaning of saying arrange them in the ascending order? The smallest element must come first. Okay, next smallest element has to come next. Next smallest element has to come next. So this is the idea. So if you have the smallest, then the next smallest, or next greatest, next, and you will get all the elements sorted. So from this list, what is that you are supposed to do? You are supposed to select the smallest element and put it first. So put the smallest element first. Next, what is that you are supposed to do? This element is used up. Next, find the smallest among the remaining elements. Find the smallest element from the remaining element and put them next. So this is the idea. So every time you have to select the smallest element. Now this is for ascending order. What about descending order? If it is a descending order, you select the largest element and put it first. So whichever is the largest element, you put first. Next largest element, you put next, and so on. That will give you in the descending order. Now, how do we go about solving this algorithm? So first, what we are going to do is we will start from this location. So this is the ith location. So I is equal to 0 means it is the first location. So we start from the ith location. Now in the ith location, you notice that I have just written it, the whole thing as is here. So in the ith location, you notice that the element that is placed in the ith location is not the proper one. It is not the smallest one. So you have to put the smallest one in this place. So what you have to do? You have to find the smallest element. So among this, go on searching and find which is the smallest element. So you find that 11 is the smallest element. Now what you are going to do? You have to get this 11 and put it in this location. So get this 11 and put it in this location. Now the question is, if you just drag this 11 from here and then say that, okay, I'm going to put it here, then what will happen is the 25 is lost. You lost one element altogether. That is not allowed. So if that is not allowed, what you are going to do? You have to first take this 25, keep it at some temporary location. So I'm going to call this one as a temporary location. You keep it temporary. So now this part is vacant. Now get this 11, put it in the first location here. What about 25? 25 cannot be kept outside this list. Replace the 25 in this location. What is this location? Wherever that 11 was there, 11 was previously in this position. So get the 11 at the proper location and put this one at the position of 11. So this how you are supposed to do the sorting. So what you are doing is you are interchanging. So you know that you are supposed to put the element in this location. Okay. Then you start comparing this element 25 with the next number. So is 72 less than 25? No. That means when you compare 72 and 25, 25 is there at the proper location because it is smaller than 72. This is ascending order. 25, then comes 78. What about the next element, 98? Again, 25 is smaller than 98, so this is proper. But when you go to the next element over here, what you notice here is you have one element 11 which is smaller than 25. So that means to say that this 11 should have come at this location and 25 it should have gone, it should have been somewhere else. So 25 is not at its right place. Instead of 11, instead of 25, 11 should have been there because 11 is the smallest element. But you cannot declare 11 as the smallest because you are not compared with the other element. So what you did was you started, let me start from here. You took the 25 and you started comparing 25 with the next element. You say whether 25 is greater than 72. No. Then you said whether 25 is greater than 98. No. But when you said is 25 greater than 11, then the answer is yes. When your answer is yes, don't immediately say that okay, then 11 must come here and 25 should go to the other location. That is interchange their location. You cannot do it. Why? Because you are not compared with the remaining element. It may so happen that there may be an element which is 7 here. Now, if you have just stopped here and then said that, okay, 25 is greater than 11, so 11 should come here. And so I'm going to put the 11 here and 25 here, interchange the location. Then this is not going to sort it because there is one other element which is smaller than 11. Then this is not going to work. So what you are supposed to do? So your now story is you start the same. You start from this location. You compare is 25 greater than 72? No. Is 25 greater than 98? No. Is 25 greater than 11? The answer is yes. So you found one element which is smaller than 25. But is it the smallest element? You don't know. Why? Because you have not compared the remaining element. Now you know that 11 is less than 25. So you start from 11. Now take this 11, not this location. I'm taking the value 11. You know that there is one number which is less than 25. So you take that number 11. Okay, is it the smallest one? You really don't know. Okay, so if it is the smallest one, well and good. If it is not, what to do? So you compare this 11 with the next element. Is 11 greater than 64? No. Is 11 greater than 36? No. Is 11 greater than 52? No. That means no other element is greater than remaining out of this all the remaining element. No other element is greater than 11. And you notice that 11 is less than 25. So now you can conclude and say that 11 is the smallest element. So 11th is, this is not the location of 11. 11 has to come to this location and 25 must go to some other location. You don't know what is it. But as of now, what you are going to do is you will bring the 11 to this first location and 25 to in the location of 11. So what is this is called as getting one element to this position and putting it back to the other. This is in your programming, this is called as swap. You are going to swap the elements. So swapping is interchanging their position. You get one to the other location, the other one to the other location. So in the A of 0, you put 11, and in the A of 3, you put 25. So as of now, what you have done is your one step is over. So 11 is there at the proper location. Next, what you do? Now get the next element. So this is there at the proper location. Go to the next location. So I is equal to 0 here. Next time go to I is equal to 1 here. Start from I is equal to 1. Start comparing. So 72, start comparing. This is I. The next element. What is the next element? If this is the ith location, what is the next location? Next location is I plus 1th location. You know very well. So if this is ith location, if this is ith location, next one is I plus 1th location. Whatever is, if I is equal to 1, I plus 1 will be 2. So here, if I is 1, I plus 1 is 2. So this is, so you compare it with the this one, this location with the other location. So if you find that 72 is not greater than 98, that means there is no problem, but 72 is greater than 25. So you say that this is one potential candidate. So 72 should have come to this position. You are not very sure, but you will say that 72 should have come to this position. Let me say this is position. So 72 must come to this position and 25 must go to the other location. Now this is not complete because you have not compared the remaining element. But as of now, you can just say that, okay, 72 is greater than 25, 25 should come. So in other words, you have to shift the 72 to this position, that is, which is this position A of 3, and you have to bring this 25 to the position of the I. So wherever this ith location was there, you have to get this one. Okay. Now, very important thing, you have not compared the remaining element. You have to compare all the elements. So this is the position. This is the position where your changing is there. But what you are going to do? You will take this position, the element in this position, that is A of 3, and you will compare it with the remaining element. Is it greater than 64? No. Is it greater than 36? No. Is it greater than 52? The answer is no. In that case, 25 is the smallest element. Now swap the position. So get this 25 to the position of 72 and get this 72 to the position of 25. So when you do it, what you're going to do is we'll go to this step now. So 11 and 25 are now in the proper position. Now again increase the I to the next location. What is I now? I is 2 now, A of 2. So take this element at the I of 2, that is this location, and then compare it with the other element. You compare it with the other element. So you say compare it with the next element. Is 98 greater than 72? The answer is yes. So 72 is the smallest one. So you say, okay, this is one position. So this is the position because 98 is greater than. So this is this should have been there. But that is not the end of it. I told you. So you can't just stop it. Now start from this position. This is the position where you found an element which is smaller than the 98. Now take this 72, compare it with the next one. What is next one? 72. Is 72 greater than 64? Yes. So 98 should have been come here. So again you say that no, this is not the original position. This is the position. This is not the position. This position. 98 should come to this one because 64 is still smaller than 72. So among these three elements, 64 is the smallest one. You say that 64 should have come here, but that is not the end. Now take this 64, which is smaller among all the three things, compare it with the next element. What you notice, 64 is greater than 36. That means 36 is smaller. So among all the four elements, 36 is the smallest. So now you say that this is not the position. This is the position where the 98 should have come. So this is the position. Okay, now that is not the end. Take the element from this position and compare it with the next element. What you notice is 36 is not greater than 52. Now you will say that, okay, so this is there is no problem because 36 is smaller than this. So among all these elements, which one is the smallest? So smallest element is 36. So this is the position where you are finding the smallest element. So position where you have the smallest element. Now what you're going to do, interchange the element. So bring 98 to this position and bring 36 to this position. So when you do it, what you're going to notice, three elements are now sorted. Now go to the next element. So this is the I. Take the I, go to the I is equal to next element. So again, start taking the position. So take the position and then say whether you are going to take the position, which is this one. So next element, compare the next element. What is the next element? This is I plus one element. What you notice? 64 is smaller than 72. So you may say that, okay, this is the position where these swapping has to be done. The answer is no, because you are not compared it with the other. Now take from 64, you compare it with the 98. Is it smaller? No. Take 64, compare it with the 52. What you notice, 52 is still smaller than 64. That means this is the position. Your original, the first position was this one was the position. Now you say that this is the position where you find the least element or the smallest element. So even though among these two, that is even though among 64 and 72, 64 is smallest, but 64 is not the smallest among all the element. The smallest is 52. So you say that this is the position, which is the position number 6. Remember, when I say position, I am talking about this position number 6, where in the position number 6 you have the element. So the swap 72 to this one and swap the other one to this one. So you are done. So now what you notice that 52 has come to this location and 72 has come to this location. So four elements are done. Now there is one other obvious problem. What is this obvious problem? Now look at this one. Now you have to find among the three which is the smallest one. You start from here, the next element I, you start from the I is equal to 4 now. I plus 1, compare it with the next element. You find 64 is smaller than 98. That means this is okay. 64 is also smaller than 72. So what you notice now is among these two things, this is the position where you find the least element. In the previous case, there was some other location where you used to find the least element. Now this is the same location. So this is the same location as the ith. I is 4, as well as the position where the smallest element is found is also 4. So this is the same location. When there is a same location, can you interchange it? This is the same location. Can you get to this one outside and bring it back? No. So if I is equal to the position, that means if the smallest element is found at the position itself, then there is no swapping. What is the meaning of saying swapping? You took this element, stored it temporarily, you brought it here, and then you bring it here. So swapping, you have done it in the first year. So swapping is not really required. So if you find that the element that you are going to replace is the proper element, that is the smallest element, there is no swapping required. Now, after this, you notice that all the elements are sorted up to here. Next, go to the next element and then compare it with the other. If it is there at the proper location, leave it. Otherwise, you interchange them. After that, you are left with one element. which is there is nothing to be compared next. So you say that there is no need for doing anything. So what you notice here is even though there are 7 elements are there, 0, 1, 2, 3, 4, up to 7, totally 7 elements are there. So your n total number of elements are 7. Compare 1, 2, 3, 4, 5, 6, 7. Totally 7 elements are there. But when you are increasing the I value, so this I started from I is equal to 0, I is equal to 1, 2, 3, 4, 5, but you didn't came up to 6. Why? Because when you came up to here, the last one will be always be there in the right location. So there is no need for comparison of the last element, because whatever is the leftover, whatever is left, that last element will be obviously there at the proper location, because that's the last element, that must be the largest element. So let us do this one. So what are the things that are required as of now? So as of now, I need a temporary location. I need a temporary location, temp, wherein I can swap this element. So if I have to get this one, here I have to put it in a temporary location. I need this temporary location so that I can swap the element. So I want one temporary variable here, temp. There is one other thing, that is I must know the position where the smallest elements are there, the position where I can find the smallest element. There is one more variable that is required. You are taking next one, you are taking I here, so I will take the value 0, 1, 2, 3, 4, 5, that is one less than the total number, you know that. But when you take this element, you start comparing it with the next element, next element, next element, next, and so on. So your comparison, you need one more counter to compare this with the other element. So you need one more variable. I am going to call this variable as j. So there is one more variable j, which is used to compare, and so on. So there are three additional variables that I'm going to use now. I'm going to just close this one. I'm going to create a four more variable. What is the four more variable? I need j, I need temp, I need position. So all four variables, extra four variables are required. Now let's look at what is the first thing that we have to do. You know very well, first thing that we have to do is we have to start from I is equal to 0, 1, 2, 3 up to n minus 1. I told you the last element is not being used up. So up to n minus 1. So let's go and say for I is equal to 0, I less than n minus 1. I told you why it is n minus 1, I plus plus. So this is done. Then you must know the position. So initially what you do. So here if you notice that initially you start this is the position. Then you say if you find a smaller element, you change and say that this is the position. So initially ith location itself will be the position. So when you have here, so for example, I say this is the element that need to be changed, but that itself is the position. So position is also same as the value of I. But later, if you find something smaller than this one, you will say that no, this is not the position, this should have been the position. Later, if you find something which is smaller than this, you will say this is not the position, no, this is the position. So initially, position will be pointing to the I itself. So I and position will be there at the same location. So I'm going to say position equal to I. Both of them are there at the location. Now what you are going to do is you will start, this is the ith location. This is your ith location. You will start comparing it with the next element, next element, next, and so on. So what is, if this is I, what is the next element? This next element is I plus 1. So if it is 0, 0 plus 1 is this. If this is I plus 1 will be 2. If this is I plus 1 will be 3, and so on. So next element is I plus 1. So you start the next loop, and I told you next loop is the jth loop, j is equal to I plus 1. Remember, you cannot use the same loop because I is there for this comparison, I is there for doing this comparison. From here, you have to do the comparison with this element, this element, this element, and so on. All of them, you can't use the same variable. So I will use the variable j. So j is equal to, from here, if this is I plus 1, then next, then next, then next, then next, up to the last element. So j is equal to I plus 1, j less than n. So go up to n, j plus plus. You do that. It is done. Now what you are doing? You are comparing. What is that you are comparing? You are comparing, if this is the element, you compare this with the next element. So this was originally, this is the position. So element in the position, is it greater than the next element? If it is so, you interchange. For example, let us look this one here. So you want to compare with the element here. So let's say this is the position where you want to compare. So you compare this element position, and which is this variable. This is not I. Remember, I is for here. This is the jth element. So this is the jth element. You compare the element at this position, that is position number 3, with the position number 2. If the element in the position number 3, if it is greater than this, in this case it is true, then this is the least one. So this will be your position. New position is this. This was the old position. Again, increment j by 1. So get it here. Compare. Is the element at this position, that is 98, is it greater than 64? Is it greater than 98? The answer is no. Then leave this as it is, increase the value of j, go to the next element. So position is still there. Is the element at this position 64, is it greater than the element at this jth location? The answer is yes. Then this will be the new position. So old position is changed. So in other words, this position will tell me the location where I can find the smallest element. Okay, so let's do that thing. So what I did, if the element at the position is greater than, okay, element at j, so this is what I did. If that is the case, then what did you say? That position POS should be there. Then you say that position is that location. So let's say, then let me go back. Then there is the enter. Then position is equal to j. So what is the meaning of this? If a of position is greater than a of j, what is this position equal to j? Let me explain this part one more time. So let's start from here. So initially, this will be my position. So this is the position. Remember, when I say this is the element, position is number 2. This is the position. Also, initially, j, value of j, will be pointing to this position. So both of them are pointing to the same location. Okay. So what is a? This is an array. A of j. Let me show that one here. Okay. What is? Let me do it here. Okay. If a of j and a of position. What is this one? A of position. So what is here? Both of them are pointing to the same location. So this j is now 2 and position is also 2. Both of them are pointing to the same location. What is a of j? A of j is 98. I'm going to take this value 98. Okay. A of position, because both of them are pointing to this one. This is also 98. Is 98 greater than 98? The answer is no. Forget it. Increase the j by 1. So j is equal to j plus 1. J was 2. 2 plus 1 will be j is 3. Now j is pointing to this location, A of 3. What is there at A of 3? A of 3, you have, sorry, this one should have been less than, less than. So A of 3, A of 3, what is there at A of 3? A of 3 is 70. I will write it just a minute. I will write this part in a slightly different way. Okay, let me write. I will type it in this one only. This is J and this is position, and this one, let me zoom in if at all you can see it. Then this one is A of J, and this one is A of position. Okay, so now let's do that thing. Initially, I'm taking about this one. Initially, J is 2, position is also 2. A of 2, A of 2 is 98. Okay, and A of position is also 98. Both of them are pointing. Both of them are pointing. This J is pointing to this location. This is also pointing to the same location, 98. Both of them are 2. Now, is this A of position, is it greater than 98 and 98? Is A of position greater than 98? The answer is no, it is not. Okay. So in that case, what you do? Increase the j by 1. J is equal to j plus 1. What is j plus 1? 2 plus 1 is 3. Now j is pointing to this location. Position is still there, same. Okay. Now compare. What is A of j? A of j is 72. So this, let me take it. So what is this? Okay. So this is A of 3 is 72. So this is 72. You notice that is 72. So you take this 7. So you notice now, say, remember, what is the use of this position? Position is there to map the smallest element. Yes, smallest element. Now where are you pointing? You are saying it 98, position is 2 here. Okay, so which is the element at this one? You are saying 98 is the smallest element, which is not true, because you find that 72 is the smallest among these two. 72 is the smallest one. So this cannot be true. So now you say that no, this 98 is not the smallest one. 72 is the smallest one. How do you say that thing? So if you find that the element which is pointed by the position is greater than the element which is pointing by the j, that is 72, you change and say that no, this is not the location. This is the location where you can find the smallest element. So what you are going to do, you are going to say that the position where the smallest element is found is not 2. The position where the smallest element found is the position where the j is pointing. Where the j is pointing? J is pointing to the location 3. So you say that position is 3. Now both j and this are pointing to the same location 3. What is the element corresponding to this location? Element corresponding to this location is 72. So you're going to say 72, not 73, 72. Now increase this j by 1. So when you increase j is equal to j plus 1, 3 plus 1 is 4. Now j is pointing to this location. J is pointing to this location. Where is the position pointing? Position is pointing to this location. So what is the element at this position? Is 72. What is the element at the position number 4? A of j. A of j, this position. What is the element? This is 64. Done. Okay. Now what do you notice again? So remember, what is the use of this position? Position will tell you where the smallest element is found. But what you notice that there is one other element which is smaller than the smallest. Now again you say this is no, this is not the position. This is the position where you find the smallest element. How do you say that? The smallest element is not found at the position 3. Smallest element is found at the position 4. Who has that position? J has that position. So you say position is 4, and what is the element at the position number 4? Element at the position number 4 is 64. Done. Again increase, still many elements are there. So again increase j by 1. So what you notice, j is 5 now. So what is the element at the location 5? The element at the location 5 is 36. So you write 36. Now again you notice that you said that the smallest element was 64 according to your position, and its position is 4 and the element is 64. But now you find a contradiction saying that there is 36 which is smaller than the position of this position. So what you notice, again you say that no, this is not the smallest element. Smallest element is found at the location 5. Who is pointing to the location 5 is the value j. So now you say that position is not the 3 4 here, position must be 5. So this must be 5, which is this value 5, which is the value of j. So element at the jth location is the smallest one. What is the element? So element at the jth location is 36. You say this is 36. Done. Okay. Now again increase j by 1. What is j plus plus? J is 6. What is there at the sixth location? Sixth location, it is 52. So in this sixth location, remember I changed the sixth location, and what is there at the sixth location? 52. What is our position is this one, 36. Now you notice that 36 and 52, this is 36 and 52, so 36 is the smallest one. So you now say that this is the position. So even though initially you said this is the position, then you said no, that's not the position, this is the position, this is the position, and finally after going through all the elements, you will say that the element which is there at this position, that is pointed out by the POS, must be the smallest one. So this is what you are doing. So what you're doing here is you are comparing, and you are saying that if the element at the position is greater than AFJ, this is what you've done. If the element, let me write this one. So for example, if the element at the position, for example, let's say this is 36 and this is 72, just I'm giving you this. If the element at the location AFJ is greater than AF position is greater than AFJ, then change the value, get the value of AF position equal to 1. So this is what you're doing. If the element at the position is greater than J, then you say no, position is not the original location. Position must be equal to the element pointed out by that. Then once you get this position, what is the next thing that you are doing? So once you know that this is the position where the smallest element is found, what is the next thing that you are doing? You interchange their location. So how do you interchange the location? You keep the AF0 in the temporary location, AFI in the temporary location, get this element here, get the element at this position to this one, and then bring this element to the other location. So this is what you are doing. So let's write that thing. Remember, however, very important thing, in this case, you know that there is a special case where I and positions are same, where I and position are pointing to the same location. That means this itself is the smallest element. In that case, there is nothing called you bring this here, bring this here, and bring it back to here. That is not going to work because that is the same location. So if I and the position are same, there is no interchanging is required. So I'm going to write that thing. So if what is this? It coming in the capital. Again, it's coming in capital. If what is that? Position is not equal to I. That means if the position is equal to I, that means to say that both I and positions are pointing to the same location. I is also this one, position is also this one. So there is this is the smallest element. No other elements are smaller than this. So there is no interchanging of this. Here you notice that 25, I is pointing to 25 and position is this one. Then there is a smaller element, you bring it here, you bring it here. That is called as swapping. Swapping is required only if I and j are not pointing to the same location. So if that's the case, then what you do? Temporarily you shift it. Temporarily you shift the a of I to this location. And then you say a of I is equal to the element that is pointed by a of position. That you have done. And then you say a of position, a of position, a of position is equal to a of I. So what did you do? So just look at here what we are doing. So first a of I is shifted to the temporary location. So for example here, let me call this one as temporary location. First a of I, this is I, a of I is changed to this location. Then a of position, remember this is the position where you find the smallest element. A of position is brought to the a of ith location, that is a of 0, and whatever that is there in the temporary location, you bring it to this location. So that is what we are doing. First get a of I into the temporary location, then get the a of position to this location, and then finally bring that this one, sorry, this is not a this one, not a of I, this is a temp. Finally bring this temp to the position of this. So that is done. So this is what we are supposed to do it. This is the 4 steps that you have to write it for sorting. Let me run it. So that's all. Let me save it and let me run this program. So I'm going to say 5 elements are there. So let me type the element 9, 90, minus 5, 6. Let me just give the element. Okay, 25. Press enter, and what you notice 9, 6, this is minus 5, 6, 9, 25, and then 90. So this is sorted. So this is what this is how you are going to sort the element. Thank you for your interest. We will meet again in the next class. Thank you.